Imagine an AI that doesn't just, answer your questions, but actually plans things out, does research, and even carries out complex tasks to reach a goal you set for it. All with like minimal human prodding.
Right.
We're talking about systems that could analyze a patient's entire medical history, sift through piles of legal documents to draft contracts, or maybe even help manage a whole hedge fund team.
Exactly.
So today we're doing a deep dive into something that's, well, it's rapidly reshaping our world. Autonomous AI agents. Forget the simple chatbots. This is AI that can think, plan, and act with, frankly, remarkable independence.
That's absolutely right. And our mission for this deep dive really is to unpack the intricate technical architectures behind these agents. We want to explore their real-world impact, especially in critical sectors like healthcare and finance. Yeah. We'll identify the key players, who's driving this innovation, and also critically examine the significant regulatory and ethical challenges they bring up. We're aiming to give you a shortcut, sort of, to truly understanding what makes these agents tick, and importantly, why they matter so much right now.
And the source material you shared with us is absolutely fascinating. I mean, it's packed with insights, real nuggets that genuinely shift how you think about AI. Okay, let's unpack this. So to kick things off, maybe the most basic question.
Yeah.
What exactly is an autonomous AI agent? How are they fundamentally different from the AI systems we've been hearing about for years? Because, for a lot of us, AI might still bring up images of a smart speaker or like a chatbot giving a canned response.
Yeah.
Agents, though, they feel like a completely different beast.
That's a crucial distinction, definitely. And it's where the deep in our deep dive really starts. At their core, autonomous AI agents are AI-driven entities that are capable of planning actions and making decisions with minimal human input. And they often do this by interacting with their environment or, other systems. The key difference here is they go beyond just responding to a single prompt or performing one predefined task.
Right.
They have a persistent memory. They can break down complex goals into smaller subtasks, and importantly, they can use external tools to achieve those goals.
Tools? Like what kind of tools?
Well, anything from searching the web, querying a database, calling an API, even running code or controlling a browser. Think of it less like a calculator that just gives you an answer, and more like a tireless, proactive assistant. You can hand it a multi-step project, and you can trust it'll figure out the individual actions needed to get it done. It's really the difference between just asking an AI a question and actually delegating a complex project to it. A very common design we see today uses a large language model, an LLM, basically as the brain of the agent.
The brain?
Yeah.
Yeah.
And this LLM operates in an iterative loop. We often call it a thought-action feedback loop.
Thought-action feedback.
Yeah.
Got it.
Exactly. So essentially, the agent generates a plan or a kind of reasoning trace. That's the thought part.
Right.
Then it executes an action. Now, this might involve calling one of those external tools we mentioned, a web search, an API, maybe running some code.
Okay.
After that action, it gets feedback. This could be from the environment or the tool itself telling it what happened. And that feedback informs its next step, its next iteration. It allows the agent to adjust its plan based on the results it got.
So it learns as it goes, in a way.
Precisely. This loop, which was inspired by reasoning frameworks like React, allows the agent not just to come up with potential solutions, but to actually try them out, learn from the outcome, and then refine its approach. It's much like how a human might try to solve a puzzle, trial and error, but informed trial and error. And the early prototypes really showed this concept in action, pushing the boundaries of what an LLM could do autonomously.
Like AutoGPT. I remember that, making waves.
Exactly. AutoGPT was a big one. It showed us that if you give an AI a high-level goal, it could actually generate its own sub-goals and actions in this continuous loop, working pretty much on its own until that goal was achieved.
Wow.
It could maintain a memory of its prior steps, remembering what it tried, what worked, what didn't, and it could use external tools like web search or code execution to actually carry out its tasks.
And Baby AGI, that was another one, right?
Yeah, Baby AGI took a slightly different tack. It organized its loop into distinct subcomponents, almost like specialized mini-agents. One for execution, one for creating new tasks based on results, and another for prioritizing those tasks.
Interesting. So different roles within the same agent.
Kind of. It was all powered by the same underlying LLM, but each component had a different prompt that defined its specific role. It was like giving the LLM different hats to wear for different parts of the process.
Okay.
This modularity combined with a vector database for long-term memory.
Vector database.
Yeah.
Can you quickly explain that?
Sure. Think of a vector database like a super smart librarian. It doesn't just categorize books by title or author, but by the ideas and concepts within them. So the AI can retrieve information that's conceptually related, even if the wording is totally different. It helps it build up knowledge over time.
Got it. Like remembering the meaning, not just the words.
Exactly. And this allowed Baby AGI to dynamically generate new tasks and constantly reprioritize its objectives based on the results it was getting. These early architectures essentially wrapped an LLM in a control harness, giving it true autonomy, the ability to remember, plan, and act, not just give a static response to one question. That's a massive shift from simple chatbots.
It really is a huge leap. But here's where it gets really interesting, at least for me. What happens when you put multiple of these autonomous agents together? Like a whole team of them working on something? That sounds like something straight out of science fiction.
It does have that sci-fi feel, doesn't it? But it's very real, and it's where multi-agent systems come into play. This significantly extends the whole concept of autonomy. Instead of just one agent chugging away, you deploy several agents that can cooperate or sometimes even compete to solve complex problems.
Okay, so multiple AIs talking to each other.
Essentially, yes. And while the idea of multi-agent systems isn't brand new, they existed well before the LLM era.
Oh, really?
Yeah, we saw them in things like belief, desire, intention agents. These were older AI systems modeling sort of human-like thought processes used in complex simulations like air traffic control, for example. But LLMs are completely reinventing them now, giving them much greater capabilities, especially around natural language understanding and reasoning.
So how does it work with LLMs? How do they coordinate?
In these newer architectures, each agent often gets a specialized role, or even a persona. This is usually defined by its specific prompt instructions. You tell one agent you're the analyst, another you're the strategist, and so on.
Yeah.
Then they communicate with each other, sharing information, maybe negotiating decisions. A great example of a framework enabling this is Microsoft's AutoGen. It allows multiple GPT-based agents to have structured conversations and divide complex tasks among themselves. It's almost like running a digital Scrum meeting automatically.
Huh. Good.
And similarly, the open source LangChain library provides tools specifically designed to orchestrate these teams of agents, where each agent might have distinct capabilities or access to different tools.
Can you give a more concrete example? Maybe in that finance context you mentioned earlier?
Absolutely. Finance is a great place to see this in action. There's been recent work creating a collaborative team of LLM agents designed to mimic a hedge fund's analytical and trading desk.
Okay, so AI traders.
More like an AI analytical team feeding into trading decisions. You might have a fundamental analyst agent digging into company reports, a sentiment analyst agent scanning news and social media, a technical analyst agent looking at charts, and maybe a risk manager agent keeping an eye on exposure. Each agent has its own specialized function.
And they talk to each other.
They do. They debate, they share insights, they combine their perspectives to inform trading decisions. You might even have additional bull and bear agents whose job is just to assess the overall market mood.
That's fascinating.
This kind of setup leverages the diversity of the agents to tackle really complex, multifaceted problems. It works especially well when tasks can be broken down or looked at from different expert angles. And some research suggests these multi-agent teams can actually outperform single agents on complex tasks precisely because of this specialization and collective reasoning. It's like getting multiple expert opinions synthesized almost instantly.
That makes sense, but doesn't it get chaotic? How do they avoid stepping on each other's toes or duplicating work?
That's definitely a challenge. Coordination issues, potential conflicts, redundant work, these are real concerns. But they're typically addressed through things like shared memory spaces where agents can see common information, or structured messaging channels that allow them to communicate efficiently, and maybe even resolve disagreements based on preset rules or a designated lead agent.
So it's an incredibly sophisticated setup, mimicking a real human team, but running at machine speed. But I have to ask, especially with something as complex and, frankly, unpredictable as financial markets, are these AI teams truly outsmarting human analysts? Or is it more about executing known strategies much faster?
That's a really critical question, and the answer is probably nuanced. Right now, they might not possess the deep intuition or the adaptive creativity of the very best human analysts, especially in truly novel or black swan type situations.
Right, the human gut feeling.
Exactly. But where these multi-agent teams do excel is in rapidly processing absolutely vast amounts of data, identifying complex patterns that humans might miss, and executing strategies with a speed and consistency that no human team could possibly match.
So it's about scale and speed.
Primarily, yes. They're often better at optimizing existing strategies or finding subtle opportunities within defined parameters. The research suggests they can achieve better risk-adjusted returns, not necessarily by being smarter in a human sense, but by being relentlessly analytical, tireless, and by integrating diverse data points much more completely than a single human or even a team of humans typically can in real time.
Okay.
So you can think of it more as augmenting and accelerating human design strategies through superior data analysis and execution speed rather than pure invention at this stage.
That clarifies things.
Yeah.
It's about breaking down a huge problem into these smaller specialized chunks and letting these AI specialists collaborate. Makes a
Yeah.
lot of sense. But you mentioned earlier it's not just about LLMs, right? They get all the headlines these days.
Hmm.
What other powerful approaches are being used to build these autonomous agents? Maybe something that's been around even longer in the AI world.
Absolutely. It's definitely not all about LLMs, although they are very prominent right now for the reasoning and planning parts. Another core architecture for autonomy comes from reinforcement learning, or RL.
Reinforcement learning, AlphaGo. Right.
Exactly. That's the most famous example. In RL-based agents, the agent learns a policy, which is basically its strategy or decision-making process through continuous trial and error interactions with an environment.
Okay.
It's guided by a system of reward feedback. It tries something, sees if it gets a positive or negative reward, and adjusts its policy to maximize future rewards. AlphaGo learned to beat human Go champions, essentially, by playing millions of games against itself and getting rewarded for winning moves.
So it learns from experience.
Precisely. And we've seen this approach used for years in very sophisticated trading bots as well. In finance, for instance, deep reinforcement learning, which combines RL with deep neural networks, has been extensively used to train trading agents for algorithmic trading and portfolio management. These RL agents observe the market state, take actions like buying, selling, or holding, and continuously improve their strategies over time to maximize returns, based purely on market feedback.
Without explicit instructions for every scenario.
Right? They learn the optimal behavior. Multi-agent RL is even used in scenarios like simulated trading competitions or complex supply chain optimizations, where multiple agents interact and learn together, which introduces fascinating concepts of game theory, equilibrium, and cooperation among AI agents.
So how do our agents compare to the LLM-based ones we were just discussing? What are the trade-offs?
It's a great question. RL agents truly excel at optimizing very clearly defined objectives through direct experience. They're like athletes who learn by doing, repeatedly trying to achieve a specific goal and getting constant feedback on every move.
Right. Practice makes perfect.
Kind of, yeah. However, they typically require huge amounts of training data, often generated through simulations, because real-world data might be too slow or risky to learn from initially. And they need very well-specified reward functions. Designing that reward signal effectively can be quite challenging.
Hmm.
Get it wrong, and the agent might learn unintended behaviors.
Okay.
LLMs, on the other hand, are incredibly strong at general reasoning, planning complex steps, and understanding natural language right out of the box, thanks to their massive pre-training on text data. They have a kind of built-in world knowledge.
Different strengths.
Exactly. And what's really exciting right now, where a lot of research is heading, is towards hybrid architectures that combine these two paradigms.
Bringing them together. How would that work?
Well, you might use an LLM for the high-level planning or strategy formation, acting as the brain that sets the long-term goals or interprets complex instructions. And then you might use an RL controller for the fine-grained, real-time decision-making and execution, perhaps optimizing the specific actions needed to implement the LLM's plan.
Best of both worlds.
That's the idea. This approach aims to marry the vast pre-trained knowledge and reasoning power of LLMs with the adaptive optimization capabilities of reinforcement learning. It creates potentially very powerful systems that leverage the strengths of both approaches.
That's a fascinating blend, using one AI strength for the big picture and another's for the nitty-gritty execution. So pulling back a bit, what really makes any of these agents truly autonomous? What are the essential building blocks, the core components that empower them to act on their own, to be more than just a sophisticated lookup table or a reactive system?
That's getting to the heart of it. There are several key enablers of autonomy, and they generally apply across these different architectures, whether LLM-based, RL-based, or hybrid. One of the most critical is the integration of tools and APIs. This is absolutely fundamental. This is
Hmm.
how agents gain actuators, ways to actually affect the world or external systems.
So they can do things, not just talk.
Precisely.
Huh.
They go beyond just generating text. By calling external functions, maybe querying a database, interacting with web services, executing code, controlling a web browser, sending an email, even manipulating an IoT device like a smart thermostat, they can perform concrete actions as part of their plan.
Right.
It's how they bridge that gap between thought and action, turning an idea or a plan into a real-world outcome.
Makes sense. What else?
Another crucial enabler is memory. Agents need to maintain state or context over multiple interactions. They can't just forget everything after each turn.
Like avoiding the goldfish problem.
Exactly. Preventing context forgetting is key, as is remembering past mistakes to avoid repeating them. This can be achieved through various mechanisms. Simpler forms include recurrent prompting, where the conversation history is fed back into the LLM each time. More sophisticated methods might use scratchpad variables to hold temporary information during a task. And for long-term knowledge, they often employ those dedicated vector stores we talked about, allowing them to build up a persistent knowledge base over time.
Right, the smart library.
Yeah, this persistence enables them to learn from past outcomes and adapt their behavior over longer periods, much like a human remembers past experiences to inform future decisions. Without memory, you don't really have autonomy, just reaction.
Okay. Tools and memory, what's next?
Then you have the decision-making frameworks. These are vital for how agents reason, plan, and choose actions. This involves planning algorithms that help them break down complex, high-level goals into smaller, manageable steps.
So they need to be able to strategize.
Yes, many agents incorporate an explicit planning step. This could be a chain of thought process where the LLM outlines its reasoning, or even a separate planning model that generates a multi-step solution before the agent starts acting.
And self-correction.
Yeah.
Can they catch their own mistakes?
Some can, yes. This is often done through self-reflection loops or using criticism prompts. It's a kind of primitive form of self-regulation where the agent evaluates its own outputs or actions, identifies potential errors or areas for improvement, and then corrects them in the next iteration. It's like the agent reviewing its own work.
That's pretty advanced.
It is. And finally, persona and goal conditioning are essential for aligning an agent's behavior. By simply instructing an agent through its initial prompt to act as a medical advisor versus a financial risk analyst, you can significantly bias its style, the knowledge it retrieves, and its decision-making process.
So you give it a role to play.
Exactly. It allows the same underlying powerful AI model to behave very differently depending on the context and the specific purpose you give it. It's like giving different instructions to a doctor versus an accountant. They use their underlying knowledge differently based on the goal. So, to sum up this part, the technical foundations of these autonomous agents are really a sophisticated blend. You have advanced AI models like LLMs or deep neural networks providing the core intelligence, combined with these iterative frameworks for memory, tool integration, planning, self-reflection, and sometimes multi-agent collaboration. It's this powerful combination that creates systems exhibiting genuinely goal-directed autonomous behavior.
Okay, I think we've got a really clear picture now of the engineering, the nuts and bolts behind these agents. Fantastic explanation. But for many of us, the real question is, how are they actually showing up in our lives right now? Where are they moving beyond the research labs and making a tangible difference, maybe even transforming industries?
That's the exciting part, isn't it? We're definitely seeing them deployed in some incredibly high-impact sectors already. Often it's in roles that augment human capabilities rather than replace them entirely, which is an important point.
Augmenting, not replacing.
Okay. Healthcare is a prime example. AI agents are already functioning there as intelligent assistants to physicians and also as autonomous monitors for patient data.
How so?
Yeah.
What are they doing?
Well, one prominent use is in diagnostics. LLM-powered agents can synthesize just enormous amounts of information from patient electronic health records, the latest medical literature, clinical guidelines to help doctors identify diseases or suggest potential treatments.
So like a superpowered research assistant.
Kind of, yeah. A great example is at Johns Hopkins Medicine. They're using an LLM-based agent that analyzes radiology reports to automatically flag critical findings. This helps radiologists prioritize the urgent cases, which can literally speed up potentially life-saving diagnoses.
Wow, that's direct impact.
Definitely. And similarly, the collaboration between Microsoft and Epic Systems EMIC makes widely used electronic health record software.
Right, I know Epic.
They've integrated GPT-4 to help draft clinical notes and patient messages. This takes a huge documentation burden off doctors, allowing them more face time with patients, while the AI ensures accuracy based on the consultation data. These agents act as powerful clinical decision support systems.
So they suggest things to the doctor.
Exactly. They can cross-reference symptoms against massive medical knowledge bases to suggest possible diagnoses, relevant tests, or next steps. And in telemedicine, which boomed recently, AI-driven triage bots, like the one used by Babylon Health, can interact with patients via chat. They gather symptoms, provide preliminary severity assessments, maybe offer some basic care advice, and importantly, escalate to human doctors only for the more serious cases.
That sounds incredibly useful for handling volume.
It is. These agents leverage natural language understanding to efficiently interview patients, assisting with initial assessments and routing them to the right level of care. And beyond diagnostics, autonomous agents are also significantly improving patient monitoring and care coordination, especially for complex conditions.
Like in hospitals.
Yes, exactly. In hospitals, multi-agent systems have been proposed and in some cases trialed for managing complex time-critical conditions. Sepsis management is a notable example.
Sepsis, yeah, that needs fast action.
It does. So imagine a framework for ICU sepsis care, where you have specialized agents working together. Maybe a data integration agent cleans and compiles patient data streaming in from ICU monitors and the electronic health record.
Yeah.
Then a diagnostic agent interprets medical scans or lab results, perhaps using deep learning models for X-rays or CTs. A risk stratification agent calculates the patient's mortality risk score based on vital signs and history.
Wow, multiple specialists.
And maybe a treatment agent suggests interventions like specific antibiotics or fluid levels based on established clinical guidelines and potentially even reinforcement learning trained on thousands of previous sepsis cases. You could even have another agent handling resource allocation, making sure ICU beds, ventilators, or special staff are assigned optimally.
And these agents coordinate.
The idea is they communicate their findings, detected infection markers, recommended drug orders to the human clinical team through some kind of unified interface, providing a comprehensive picture.
Is anything like that actually deployed?
Well, a powerful real-world parallel exists in FDA-approved AI monitoring software. Viz AI's stroke detection agent is a great example. This system automatically analyzes brain CT scans for signs of large vessel occlusion stroke and alerts the entire neurospecialist team in real time, often before the radiologist has even finished their formal review.
So it speeds up the alert.
Massively. By notifying specialists of critical findings faster, these autonomous triage agents help get treatment started much sooner, which can dramatically improve patient outcomes after a stroke.
That's incredible.
But, and this is crucial, it's vital to emphasize that almost all these systems currently work under human oversight. The AI flags issues, makes suggestions, drafts notes, but a human doctor confirms the findings and makes the final decision on what actions to take.
So they're tools for the doctor, not replacements.
Precisely. In healthcare, these AI agents are acting as force multipliers. They're like having an always-on, hypervigilant assistant, continuously monitoring vital signs and images, aggregating complex data, and providing decision support. They augment clinicians' capabilities, from busy hospitals to remote telehealth settings.
That's incredibly impactful for healthcare, truly transformative potential there, easing workloads and potentially saving lives. It's exciting stuff. Now, what about the other high-stakes arena you mentioned, the fast-paced world of finance? We hear about algorithms constantly in trading, but how are these truly autonomous agents changing the game there? Are they really giving human traders a run for their money?
The finance sector has definitely been an early adopter of autonomous algorithms, you're right about that. And today's more advanced AI agents powered by LLMs and RL are pushing that evolution even further, impacting trading, investment strategies, and risk management significantly.
So beyond just high-frequency trading.
Yes, much beyond. In algorithmic trading, AI agents, often using deep reinforcement learning or sometimes evolutionary strategies, are not just executing trades at high speed, but are also optimizing complex portfolios. For example, some trading firms have developed RL-based agents that learn optimal buy-sell strategies directly from interacting with dynamic market data. And studies have shown these can actually outperform some traditional rule-based strategies because they can adapt to complex, changing price patterns that rules might miss.
Learning to trade on their own.
Within defined parameters, yes. And remember that multi-agent hedge fund example?
Yeah, the team of AI analysts.
Exactly. Frameworks like trading agents used distinct LLM agents, fundamental analysts, technical analysts, sentiment analysts, maybe even traders with different risk tolerances to analyze everything from financial statements and news feeds to social media chatter and price charts.
All at once.
Pretty much. They then debate and collaborate on trading decisions, maybe with those bull and bear agents assessing the overall market vibe, and a risk manager agent keeping tabs on exposure. Early experiments suggest this multi-agent approach can yield better returns and risk-adjusted performance compared to single-model baselines, precisely because it integrates such diverse information streams and perspectives.
So it's not just stocks.
No, banks are exploring AI agents in areas like foreign exchange trading, derivatives pricing, and asset allocation, too. These agents can continuously adjust positions based on streaming data like market prices, economic indicators, geopolitical news, you name it. They operate within strict human-set constraints. Of course, things like risk limits or compliance rules are hard-coded.
Guardrails.
Absolutely essential guardrails. But within those, they can react to market movements in milliseconds, which is just a necessity in today's electronic market.
Okay, trading makes sense. What about risks? You mentioned risk analysis.
Yes, risk analysis and management is another huge area. Large financial institutions are deploying LLM-based agents to monitor for fraud, ensure compliance with regulations, and manage various market and operational risks.
Like finding fraud automatically.
Exactly. Take Visa, for example. Their AI-driven fraud detection system, which incorporates LLM techniques, reportedly helped prevent something like $27 billion in fraudulent transactions in 2023. It acts as an autonomous agent, scanning millions of transactions in real time, identifying anomalies or suspicious patterns, and flagging them for human investigation much faster than humans could alone.
$27 billion. That's staggering.
It is. And in investment banking, JP Morgan made headlines with concepts like Index GPT, using generative AI to analyze market data and research reports to give clients investment insights or ideas for new index products. And remember, JP Morgan's earlier AI agent, Koyan Contract Intelligence, that's been autonomously reviewing commercial loan agreements and other legal documents for years now. It can parse thousands of pages in seconds, extracting key clauses or identifying risks, a task they estimated previously took around 360,000 hours of lawyer and loan officer time annually.
Wow. Automating legal review.
Yes, by acting as an autonomous document review agent, Korainen drastically cut down the human workload in compliance and due diligence tasks.
What about personal finance? Like for advisors or individuals?
Good question. In wealth management, Morgan Stanley rolled out an AI assistant for its financial advisors, powered by GPT-4. This agent can instantly answer advisors' questions by surfing the firm's huge library of internal research, market commentary, and policy documents. It basically gives each advisor a tireless, autonomous researcher they can consult during client meetings.
A personal research assistant for every advisor.
Pretty much. And portfolio optimization is also being enhanced. AI agents can suggest portfolio rebalancing moves tailored to a client's specific risk profile and the latest market forecasts. These agents digest news, run scenario analyses, and generate recommendations, like suggesting a shift in asset allocation if they predict a recession risk is rising, which the human advisor can then evaluate and discuss with the client.
So, again, augmenting the human.
Overwhelmingly, yes. It's really important to reiterate that most of these finance implementations, especially those directly touching client money or making regulated decisions, operate with significant human oversight and final say. The stakes are just too high.
Makes sense.
Banks and investment funds primarily use these AI agents as a form of augmented intelligence. They inform decisions, speed up analysis, handle routine tasks. But compliance officers, risk managers, and portfolio managers remain firmly in the loop to ensure everything aligns with regulatory requirements, ethical guidelines like fair lending laws, and their fiduciary duties to clients. So, while incredibly powerful, they're still working with human experts, not replacing them wholesale, especially in judgmental roles.
Those are truly astounding figures for saved hours and fraud prevention. The efficiency gains are undeniable. But I imagine with such power, especially in finance, there must be equally significant risks or implementation hurdles involved, right?
Oh, absolutely. The risks are substantial, and the implementation requires extreme care. We'll definitely dive into those challenges: accountability, bias, security in a bit. They're critical.
Okay. And it also makes me wonder, how quickly are other industries adopting these agents? We've hit healthcare and finance hard, but what about sectors that are maybe traditionally a bit slower to embrace cutting-edge tech?
That's a great point. While healthcare and finance were early movers due to the sheer volume of data and potential ROI, the adoption is indeed spreading rapidly across many other industries, even in some traditionally more conservative sectors. Autonomous agents are finding footholds in numerous other high-impact domains.
Like where else?
Well, take supply chain and logistics, for example. This is a field rife for optimization. Multi-agent AI systems are really transforming how supply chains are managed. They allow different parts of the chain, manufacturing, warehousing, transportation, to make coordinated decisions autonomously.
How does that work in practice?
You could have different agents specialized for different tasks. One agent might continuously analyze sales data, weather patterns, economic indicators to forecast product demand with high accuracy. Another agent manages warehouse inventory levels, automatically triggering reorders when stock runs low. And yet another plans optimal delivery routes for trucks, reacting in real time to traffic jams or delivery changes.
So they all work together.
Exactly. This distributed intelligence makes the entire supply chain incredibly adaptive. If a sudden disruption hits, say, a major port closes or a supplier's factory has an issue, these agents can collaboratively replan sourcing, inventory positioning, and transportation routes on the fly, minimizing the impact.
That sounds incredibly resilient.
It is. There was a compelling case study describing an autonomous supply chain for a meat distributor. Their agents automated wholesale ordering and logistics decisions, leading to much faster responses to market price fluctuations and more resilient operations overall. And of course, giants like Amazon and Walmart have invested heavily in AI-driven warehouse robotics and delivery route optimizers for years now. These are essentially sophisticated agent-based systems coordinating fleets of robots and delivery vehicles.
Right, Amazon's warehouses.
Yeah. The end result is moving towards a supply chain that almost thinks for itself. It improves efficiency by autonomously handling countless routine decisions: when to restock, which supplier to use, which truck to load, with humans stepping in mainly for major exceptions or strategic long-term planning. It's like having an entire supply chain management team that operates 24/7 at optimal efficiency.
Okay, supply chains make a lot of sense. What about something like law? That feels like a very human-centric field.
You'd think so, but legal tech and compliance is another area seeing significant inroads from AI agents. They're increasingly assisting lawyers and compliance officers by autonomously handling some of the more tedious, time-consuming, yet critically important tasks.
Tedious tasks like what? Document review.
Exactly that, and more. A leading example is a startup called Harvey AI. They provide what's essentially an AI lawyer trained on vast legal datasets. Harvey's agent can help draft initial versions of contracts, review large volumes of documents for specific clauses during due diligence, or even answer legal research questions in plain language.
An AI lawyer. That's bold.
It is. But by 2025, Harvey's tools were already being adopted by major international law firms and corporate legal departments. Why? Because they can rapidly produce first drafts of standard agreements or summarize mountains of evidence files in minutes, tasks that used to take junior lawyers hours or days.
Saving lawyer hours, like the coin example.
Precisely. And crucially, for these legal agents to be useful and gain lawyers' trust, they need to be custom trained for legal accuracy and ideally be able to cite the sources or legal precedents backing up their statements.
Right, explainability is key there too.
Absolutely. And in the compliance world, banks and other regulated industries are using agents to monitor the ever-changing regulatory landscape. An AI agent might scan new regulations or sanctions lists published daily and automatically flag specific items that require the company's internal policies to be updated.
Keeping up with the rules automatically.
Yes. And we already mentioned JP Morgan's Coin reviewing contracts. Similarly, other banks use AI agents to review customer communications emails, chat logs for potential compliance violations, or to autonomously perform parts of the KYC or Know Your Customer checks required for onboarding new clients.
What's the main benefit there? Speed,
Yeah,
accuracy.
both, really. These legal and compliance agents can significantly raise accuracy and consistency because, well, they don't get tired, they don't miss details buried in fine print, and they apply rules uniformly. But the final decisions, like actually filing a legal motion or submitting a report to a regulator, still firmly rest with human professionals.
So augmentation, again.
Yes. The promise isn't replacing lawyers, but offloading the routine work document discovery, filling contract templates, checking compliance forms, allowing humans to focus on higher-level strategy, negotiation, and judgment. A Goldman Sachs analysis back in 2023 estimated that something like 44% of legal tasks could eventually be automated by AI. That gives you a sense of the potential impact here.
44%. That's huge. Okay, one more area. What about cybersecurity? That seems like a constant battle, getting faster all the time.
It absolutely is. And cybersecurity is another domain where autonomous agents are poised to make a massive difference simply because the speed and volume of threats are overwhelming human defenders.
How can agents help there?
They can act as tireless digital sentinels. AI agents are being developed to ingest and analyze enormous streams of data in real-time system logs, network traffic patterns, user behavior analytics to detect anomalies or sophisticated attacks far faster than even large teams of human analysts can.
Finding the needle in the haystack.
Exactly. Microsoft's Security Copilot, announced in 2023, is a good example. It uses an advanced GPT-based agent integrated into their security platform. It helps Security Operations Center, or SOC, teams by summarizing complex security incidents, finding relevant threat intelligence from global sources, and even suggesting remediation steps, all in natural language.
So it helps the human analysts work faster.
Yes, significantly. And looking ahead, experts predict AI agents will take on even more active defense roles, not just detecting, but autonomously responding.
Responding how? Like blocking attacks.
Potentially, yes. Microsoft's H. Rajub forecasted that within a year or two, AI agents would be able to automatically execute defensive actions across a network, like isolating a compromised machine or blocking malicious IP addresses to achieve specific security goals set by humans. And even more intriguingly, they might be able to modify their own defensive strategies to adapt to novel or evolving attacks.
Self-adapting defenses.
That's the vision. Future security agents could potentially self-improve their detection rules or response playbooks based on what they observe, possibly even handling zero-day threats attacks, exploiting previously unknown vulnerabilities at machine speed. Startups are already emerging in this space, building agents that continuously probe a company's own systems for weaknesses, like an automated red team, constantly trying to break in to find holes before the real attackers do.
But doesn't that create a risk of AI attackers too?
That is the flip side, and a major concern. Malicious actors could develop their own autonomous agents, perhaps AI-driven malware that adapts its tactics to evade detection. This has led cybersecurity experts to talk about an emerging era of agent versus agent conflict where defender AI agents will need to constantly battle attacker AI agents in a high-speed, digital cat-and-mouse game.
Wow, that's a whole new level of cyber warfare.
It is. And while fully autonomous cyber defense is still nascent and carries risks, certain tasks are already commonly handled or augmented by AI today, filtering the overwhelming flood of security alerts to reduce false positives, automatically isolating potentially compromised devices to contain threats, generating incident reports.
So focusing humans on the real threats.
Exactly. Experts caution, though, that human expertise absolutely must remain central. Devising long-term security strategy, handling highly sophisticated nation-state attacks, making critical judgment calls under pressure. These are not tasks likely to be fully automated soon, given the creativity and ingenuity of human adversaries. But AI agents are set to revolutionize the SOC by automating routine defensive measures and equipping analysts with rapid insights, dramatically shortening response times to incidents.
That's a truly comprehensive picture of where these agents are already making waves. It really sounds like they're starting to touch almost every corner of the economy, from healthcare to law to keeping our networks safe. So given this rapid spread, who are the big names? Who are the innovators, the game changers, really pushing the boundaries in this space? Who should we be watching?
That's a great question because the autonomous agent boom has really fostered a vibrant and diverse ecosystem. It's a mix of established tech giants laying the foundation, agile startups tackling specific problems, and crucially, collaborative open source communities accelerating everything.
Okay, so let's start with the giants. Who's leading the pack there?
Well, you absolutely have to start with OpenAI and Microsoft. OpenAI's models, particularly GPT-4 and its successors, are often the brain powering many of these agents, thanks to their strong reasoning and language capabilities.
Right, they provide the engine.
Exactly. OpenAI has also introduced really critical enabling tools like function calling, which lets the LLM decide to call external tools, and the concept of GPTs, which are essentially customizable mini agents users can build for specific tasks, enabling quite complex workflows without deep coding.
And Microsoft's role, beyond just investing in OpenAI.
Microsoft is deeply involved. They've developed their own powerful frameworks like AutoGen, which we mentioned, specifically designed for coordinating conversations between multiple agents, and they're aggressively integrating autonomous AI capabilities directly into their core products. Think GitHub Copilot for coding assistance.
Use it all the time.
Right. It acts like an agent helping developers write, debug, and understand code. And then there's the broader Microsoft 365 Copilot, designed to operate Office applications like Word, Excel, PowerPoint, Teams on your behalf based on natural language commands.
So agents embedded in everyday software.
Precisely. Microsoft's research has also been influential, even showing early interest in agent orchestration with projects like Jervis, also known as Hugging GPT, which demonstrated how an LLM agent could act as a controller, selecting and calling other specialized AI models, like image recognition models, as tools to solve complex, multimodal tasks. Together, OpenAI and Microsoft are also trying to set standards for responsible deployment, putting a strong emphasis on safety guardrails and often requiring explicit user approval before an agent takes significant autonomous actions.
Okay, OpenAI and Microsoft are key. Who else among the big players?
You absolutely have to talk about Google DeepMind. They are a true powerhouse in AI research, bringing together Google's Brain team and the original DeepMind. DeepMind, of course, has that incredibly rich history in reinforcement learning agents. AlphaGo, AlphaZero are legendary examples.
Right, the game-playing AIs.
Yes, but they've also done extensive research into multi-agent simulations. Their XLAN project, for instance, trained agents in a vast game-like 3D world with thousands of potential tasks, leading to agents that showed remarkable open-ended learning abilities and could generalize to new challenges.
Wow.
And back in 2022, DeepMind's Cicero agent achieved a stunning result. Human-level performance in the complex negotiation game diplomacy by actually collaborating and negotiating effectively with human players. This is a very early and impressive example of an LLM being used successfully in a competitive, multi-agent setting involving humans.
Diplomacy is all about trust and deception. That's amazing.
It really was. And Google is actively integrating agent-like capabilities into its services. Google's Bard AI, now Gemini, can already use tools like search or maps autonomously to answer queries, and their upcoming, more powerful Gemini models are expected to significantly enhance these agentic capabilities further. Plus, DeepMind's ongoing research into crucial areas like agent alignment and safety things like scalable oversight and reward modeling is hugely influential in the global effort to ensure these powerful autonomous agents actually behave as intended and remain beneficial.
Okay, Google DeepMind, definitely one to watch. Who else is critical in the foundational model space?
Anthropic is another key AI startup that deserves mention. They have a very strong focus on building aligned, helpful, and harmless AI systems. Their Claude series of LLMs, like Claude 2 and now Claude 3, are increasingly used as the foundation for agents, especially in applications where safety, reliability, and maybe explainability are paramount.
Our focus is safety.
Very much so. Anthropic's research on techniques like constitutional AI is really interesting. It involves giving the AI a set of core principles or rules to follow, like a constitution, which helps it self-regulate its actions and refuse harmful requests, contributing directly to making autonomous agents that adhere more closely to human values. While they primarily provide the general models, they collaborate closely with partners to implement these safely in sensitive fields like finance and healthcare. For example, some hospitals have been testing Claude for patient interaction agents, partly due to its large context window for processing long medical histories and its built-in safety features.
Constitutional AI, that's a fascinating concept. Now, are there startups focused specifically on building agents, not just the underlying models?
Yes, absolutely. A very notable one is Adept AI. They are building an AI called ACT-1, and its whole purpose is to perform actions on a computer just like a human would, clicking buttons, typing text, navigating different software applications.
So it controls the mouse and keyboard.
Essentially, yes, but intelligently based on natural language commands. Adept's vision is to create an AI teammate that you can just tell, in plain English, to execute complex business processes that span multiple different apps. Imagine saying, hey, find the latest sales report, summarize the key trends, put them in a slide deck, and email it to the team. The agent would then operate your spreadsheet software, presentation software, and email client to get it done.
Wow, that's like a universal remote for software.
Kind of. It requires sophisticated computer vision, the ability to see and understand what's on the screen, combined with action capabilities. Adept trains its models using demonstrations of humans performing these tasks. They represent a significant wave of startups focused purely on enterprise automation, using agents to handle repetitive digital tasks like data entry, report generation, cross-system updates, often even without needing traditional APIs because they can interact directly with the user interface just like a person.
That could automate a lot of office work.
Potentially, yes. And beyond these players focused on general models or general computer actions, we're also seeing a huge rise in domain-focused AI startups building specialized agents.
We mentioned some already, right?
We did. In healthcare, companies like Viz.ai with their stroke detection agent and ADOC, another leader in medical image analysis, have deployed FDA-cleared AI agents that are directly involved in care coordination and diagnostics.
And in law.
In legal tech, Harvey AI, which we discussed, has become a very prominent player, striking partnerships with major law firms and integrating with legal databases like LexisNexis to offer a powerful AI legal research and drafting assistant. Its rapid rise and multi-billion-dollar valuation by 2025 really underscore the massive demand for effective AI agents in professional services. Contract Podeye and Eigen are other players in the contract analysis space.
Finance, too.
Definitely. Beyond the big banks building their own systems, you have fintech startups integrating agents. Kasisto's KAI, for instance, is an AI chatbot agent used by several banks to handle front-end customer service inquiries, effectively acting as an autonomous virtual banker available 24/7. And numerous insurtech startups are using AI agents to streamline claims, ingesting claim documents, assessing damage photos, checking for fraud indicators, and sometimes even automatically approving straightforward claims.
So specialized agents for specific industry problems.
Exactly. They focus on solving particular pain points very effectively. But there's one more crucial part of this ecosystem we absolutely have to talk about.
Which is?
The open source frameworks and communities. Their impact has been enormous in accelerating development and adoption. Well, remember those early prototypes like AutoGPT by Significant Gravitas and Baby AGI by Yohei Nakajima? They went absolutely viral in 2023. While maybe a bit rudimentary in hindsight, they powerfully proved the concept that LLMs could iteratively self-prompt to achieve complex goals. This just ignited a huge wave of community-driven development and experimentation.
Lowering the barrier to entry?
Massively. Frameworks like LangChain became incredibly popular almost overnight. LangChain provides modular building blocks components for managing prompts, connecting to tools, handling memory, making it much easier for developers to assemble their own custom agents without starting from scratch. It spawned a whole ecosystem of related tools and libraries.
So democratizing agent creation.
To a large extent, yes. Newer libraries built on similar ideas, like LangGraph, introduce more sophisticated ways to define agent workflows, particularly for multi-agent systems, using graph structures. Microsoft also contributed open-source tools like PromptCraft and Guidance, offering templates and controls for agent behaviors.
Man, Hugging GPT. Was that open source?
The research paper proposed the Hugging GPT concept, using an LLM to orchestrate calls to various specialized models hosted on the Hugging Face platform, which is a major hub for open-source models. While maybe not a single downloadable framework initially, the idea heavily influenced the community towards building agents that could leverage a diverse toolkit of AI models. More recently, we've seen frameworks like Crew AI emerge, specifically designed to make it easier for developers to configure and manage a team of role-playing agents collaborating on a task.
True AI.
This vibrant open-source ecosystem, often curated on platforms like GitHub with awesome lists that aggregate hundreds of agent projects and tools, has dramatically lowered the barrier for anyone from individual researchers to startups to large enterprises to experiment with and deploy autonomous agents for an incredibly wide range of uses. It means innovation isn't just happening inside the big tech labs, it's happening everywhere. Even smaller companies or research groups can now create quite sophisticated bespoke agents, maybe a personalized learning tutor, a supply chain optimizer, or a game-playing bot by leveraging these shared libraries and readily available pre-trained models. So, to quickly summarize this segment, the development of autonomous AI agents is truly a global cross-industry effort. You have the tech giants providing the foundational brain power through their large models and cloud platforms, while also spearheading critical research in safety and scalability. Then you have agile startups translating that foundational tech into specialized products that solve very specific industry pain points, automating a legal brief, optimizing a trading strategy, managing a warehouse. And underpinning it all, you have these collaborative open source communities driving incredibly rapid innovation, sharing knowledge, and making the tools accessible to everyone. It's this powerful synergy that has propelled the field from, frankly, niche research prototypes to tangible, real-world deployments remarkably quickly, mostly just within the last couple of years.
That's a fantastic overview of the landscape. It really feels like a confluence of forces driving this forward. But as you hinted earlier, this technology is incredibly powerful, clearly capable of transforming entire industries. And with great power comes, well, you know the rest. What are the inherent risks? What are the big ethical and regulatory hurdles we absolutely need to clear as these agents become more common and more autonomous?
You're right to bring that up, and it leads to perhaps the most critical questions surrounding this technology. When autonomous agents make decisions that profoundly affect people's lives, whether it's a medical diagnosis, a loan application, a hiring decision, or even a stock trade, who is ultimately responsible if something goes wrong?
Yeah, the accountability question. That seems huge.
It is enormous, and it's at the absolute forefront of policy debates and regulatory efforts worldwide. This accountability and safety question is paramount because mistakes will inevitably happen.
So if an AI agent makes a mistake, say, a misdiagnosis in healthcare leading to patient harm, or an erroneous credit denial preventing someone from buying a home who is liable, the developer, the user, the AI itself.
Well, the AI itself certainly can't be held legally liable currently. The focus is on the humans and organizations involved. In healthcare, a misdiagnosis by an AI could have devastating consequences. Recognizing this, regulators like the U.S. Food and Drug Administration, FDA, have started treating certain diagnostic AI agents, especially those that provide specific recommendations rather than just information, as medical devices.
As medical devices, like a pacemaker or an MRI machine.
In terms of regulatory oversight, yes. They need to undergo pre-market approvals, demonstrate safety and effectiveness through clinical validation, and adhere to quality control standards, much like hardware devices or drugs. The FDA even created a new regulatory category for ML-based clinical decision support software back in 2018 and is continually developing frameworks to handle adaptive AI systems that learn and change over time after deployment.
But who's responsible if it gets it wrong in the hospital?
The current line generally drawn, both legally and ethically, is that the human medical provider, the doctor, the nurse, is still ultimately responsible for patient care decisions. The AI's output is typically considered advisory, a tool to inform their judgment. Regulations often mandate human oversight. For example, the European Union's Comprehensive AI Act explicitly requires human review capabilities for high-risk AI decisions, ensuring that healthcare professionals can always validate, question, or override an AI agent's recommendations before they impact a patient.
Okay, so human oversight is key in healthcare. What about finance? Creating algorithms have been around for ages.
True, but the level of autonomy and complexity is increasing dramatically. Financial regulators like the Securities and Exchange Commission, SEC, and banking authorities worldwide are similarly wary of fully autonomous trading or lending decisions happening without clear human accountability structures in place.
They're worried about flash crashes or unfair lending.
Precisely. The Federal Reserve and the FDIC in the U.S. have emphasized repeatedly that banks using AI or machine learning doesn't absolve them from the need for robust model risk management practices and strong oversight by senior management. If an AI trading agent were to malfunction and cause a market disruption, or if a lending AI systematically discriminated against a protected group, the financial institution deploying that agent would almost certainly be held liable.
So how are firms handling this?
They're implementing governance structures. This often means requiring human sign-off for certain high-stakes AI-driven decisions, establishing clear escalation paths for when an agent encounters uncertainty or an edge case. It wasn't trained for maybe a stop rule that automatically hands control back to a human if the AI's confidence score drops below a certain threshold.
Makes sense.
And ensuring safety also means addressing systemic risks. Regulators are concerned about the potential for rogue autonomous trading agents to jeopardize overall market stability. So we might see requirements for specific fail-safe mechanisms like mandatory kill switches to instantly disable misbehaving agents, or perhaps additional capital buffers for firms heavily reliant on autonomous trading systems. The core principle emerging across regulated sectors is clear. AI agents can assist, they can augment, they can automate, but they cannot possess unchecked authority in high-stakes matters. The regulated entities, the hospitals, the banks must maintain accountability for the outcomes.
That accountability piece is critical. And you mentioned earlier these agents need data, often vast amounts of sensitive data, patient records, financial transactions, personal details. That immediately brings up the huge issue of data privacy, doesn't it? The more autonomous they are, the more data they potentially access, and the more careful we need to be.
Absolutely. Data privacy and security are enormous concerns, running parallel to accountability. Autonomous agents, by their nature, often need to consume and process huge volumes of sensitive data to function effectively. This immediately triggers compliance requirements under existing privacy laws globally.
Like IPO in the US for health data.
Exactly. In healthcare, any agent handling patient information must comply strictly with IPO in the US or similar data protection laws elsewhere. This means patient data must be robustly anonymized or pseudonymized where possible, encrypted both in transit and at rest. Access must be tightly controlled, and usage must be limited strictly to the intended purpose, like diagnosis or treatment planning. If the AI agent is hosted in the cloud, hospitals need to ensure their cloud provider signs appropriate agreements, like business associate agreements under HIPAA, which legally bind the provider to protect that patient data.
And in finance, GDPR comes to mind in Europe.
Yes, GDPR in Europe is a major factor, alongside various banking secrecy laws and financial privacy regulations globally. These laws restrict how customer financial data can be collected, processed, and stored. GDPR, for instance, is particularly relevant because it grants individuals specific rights regarding decisions made solely by automated means that have significant legal or similar effects on them.
What kind of rights?
Rights like the right to be informed about the automated decision-making, the right to obtain human intervention, the right to express their point of view, and the right to contest the decision. So, if an autonomous AI agent denies someone a loan, flags their transaction as fraudulent, or maybe even sets their insurance premium, that could trigger these GDPR Article 22 provisions. Ensuring compliance often means either keeping a human reviewer in the loop for final decisions or obtaining very explicit consent from the individual for fully automated processing, along with providing clear explanations.
That sounds complicated to implement.
It can be. And beyond compliance with existing laws, autonomous agents also introduce new vectors for security breaches themselves.
How so?
Well, malicious actors could try to attack the agent directly. One method is data poisoning, where they subtly corrupt the data the agent is trained on, hoping to skew its outputs or create hidden backdoors.
Wow.
Another emerging threat is prompt injection attacks, specifically targeting LLM-based agents. An attacker might craft inputs designed to trick the agent into ignoring its original instructions and performing unintended or harmful actions, like revealing sensitive data or executing malicious code.
So the agent itself becomes a vulnerability?
Potentially, yes. Regulators are highly alert to these cybersecurity risks associated with AI adoption. The U.S. Treasury, for example, issued a report in 2023 based on public input about AI in the financial sector, specifically highlighting risks of data breaches, model tampering, and the potential for AI to be exploited by attackers. The report underscored the expectation that firms adopt strong data security practices, robust monitoring, and thorough vulnerability testing when deploying AI systems.
So what's the bottom line for companies using these agents?
The bottom line is that autonomous agents must be developed following privacy by design and security by design principles from the very beginning. Organizations deploying them need to enforce strict data governance, implement state-of-the-art security measures like encryption and access controls, maintain detailed audit trails of agent actions and data access, and conduct rigorous ongoing testing for vulnerabilities. If they don't, they face not only potentially crippling regulatory fines and lawsuits for privacy violations, but also a devastating loss of customer trust, which can be even harder to recover from.
Okay, so accountability and privacy are massive hurdles. But what about the situation where the AI makes a decision and we simply can't understand why it made that decision? That seems like a huge trust issue for the individuals affected and potentially a regulatory nightmare for the institutions using the AI. It feels like the classic black box problem, but amplified because the agent is acting autonomously.
You've hit on another core challenge: transparency and explainability. What's particularly challenging here is precisely that black box nature you mentioned, especially with the complex deep learning models that often power the most capable agents. Their internal workings can be incredibly opaque, making it hard to pinpoint the exact reasons for a specific output.
And why is that such a problem? If it's accurate, it doesn't matter how it got there.
It matters enormously for several reasons. Both healthcare and finance regulators are increasingly stressing that AI decisions need to be transparent and explainable, especially when they significantly affect individuals' rights, safety, or financial well-being.
Okay, explain why. In healthcare first.
In healthcare, this opaqueness is deeply problematic from an ethical and legal standpoint. Clinicians are expected, and often legally required, to base patient care decisions on sound clinical reasoning. If an AI agent suggests a particular diagnosis or treatment plan, doctors need to understand why. Was it based on specific symptoms, certain test results, a pattern recognized from thousands of similar past cases? Without that understanding, they can't properly evaluate the recommendation, take responsibility for it, or explain it adequately to the patient.
So doctors need to trust and verify.
Exactly. And regulators are enforcing this. The EU AI Act, for instance, will impose strict requirements on high-risk AI systems, including most diagnostic and treatment support agents. They'll need to provide clear documentation about how they work, how they were trained and validated, and ensure their outputs are sufficiently transparent or explainable to the intended users, both the medical professionals and, where appropriate, the patient. This might involve the AI highlighting the key factors it considered, citing supporting medical literature, or showing similar anonymized cases from its training data.
And in finance, why is explainability critical there?
In finance, explainability is crucial for both regulatory compliance and customer trust. Take lending, for example. In the U.S., regulations like the Equal Credit Opportunity Act, ECOA, require lenders to provide specific reasons when they deny credit to an applicant.
Right, the adverse action notice.
Precisely. If an autonomous underwriting agent rejects a loan application, the bank must be able to generate that notice with clear, understandable reasons like insufficient income or high debt-to-income ratio, not just spit out an opaque credit score generated by a black box algorithm. Failing to provide adequate reasons is illegal.
So black box models are a non-starter for loan decisions.
For the final decision, often yes, or they need to be paired with an interpretable layer. As a result, many banks currently use complex AI agents more in advisory roles or for specific parts of the risk assessment process, like fraud detection, while ensuring that the final models making critical credit decisions remain simpler and more interpretable. The New York Department of Financial Services issued guidance in 2023 urging financial institutions using AI to ensure they have robust testing and that their staff can actually interpret model outputs that affect customers.
And the trust issue.
It's huge. A lack of explainability fundamentally undermines trust. Patients might be hesitant to accept an AI-influenced diagnosis if the reasoning is unclear. Investors won't trust an AI trading agent if they can't get a coherent explanation for its strategy beyond some mystifying prediction. This trust deficit can severely hinder adoption, regardless of the AI's technical accuracy.
So what are the solutions? How do we make these agents more transparent?
There's a whole field of research called explainable AI, or XAI, dedicated to developing techniques for this. Methods range from designing inherently more interpretable models from the start, like simpler rule-based systems or linear models where possible, to developing post hoc explanation methods that try to approximate or highlight the key factors driving a complex model's decision for a specific case.
Like showing its work.
Kind of, yeah. For LLM-based agents, techniques like retrieval augmented generation, RAG, where the agent explicitly retrieves and cites specific source documents or data points supporting its answer, can significantly improve transparency. Some respondents to that Treasury RFI we mentioned suggested mandating RAG for financial advice agents. We're likely to see a regulatory push for using transparent boxes wherever feasible, perhaps reserving the more opaque deep learning models only for problems where their accuracy advantage is truly indispensable, and even then requiring extremely rigorous validation, detailed model documentation about training data, architecture testing, and ongoing monitoring for unexpected behavior.
Okay, that makes sense. But perhaps the biggest concern for many people when they think about AI making important decisions is fairness. Could these powerful autonomous agents inadvertently bake in or even amplify existing societal biases, leading to genuinely unfair or discriminatory outcomes? That seems like a critical ethical challenge to overcome.
It is indeed, and bias and fairness represent arguably one of the most critical ethical and societal challenges posed by autonomous agents. There's a very real risk that these systems can inadvertently mirror, perpetuate, or even amplify societal biases that are unfortunately present in the historical data they're trained on, or sometimes even biases introduced by the design choices of their developers.
Leading to discrimination.
Potentially, yes, leading to unfair or discriminatory outcomes in crucial areas like hiring, lending, healthcare access, insurance pricing, even law enforcement. This is a top-tier concern for regulators, civil society groups, and responsible AI developers across all domains.
Can you give an example in healthcare?
Sure. Imagine an AI diagnostic agent trained primarily on medical images or health records from one demographic group, say middle-aged white men. It might consequently perform less accurately when used on patients from other groups, women, minorities, older adults, simply because their data was underrepresented or looked different in the training set.
So it could worsen existing health disparities.
Exactly. It could inadvertently exacerbate existing inequalities in healthcare access or quality. Recognizing this risk, regulators like the FDA and health authorities globally are increasingly requiring developers to provide evidence that their AI systems have been rigorously tested for bias and perform safely and equitably across diverse patient populations. The EU AI Act specifically designates bias detection and mitigation as a core requirement for high-risk AI systems throughout their lifecycle.
And in finance, we touched on lending.
Finance is another area where the potential for bias is extremely acute and heavily scrutinized. AI agents used in credit scoring, loan underwriting, fraud detection, or insurance pricing could inadvertently learn to discriminate based on protected attributes like race, gender, age, or location, even if those factors aren't explicitly fed into the model. They might learn correlations through seemingly neutral proxy variables like postcode being correlated with race in some areas.
So it might deny loans unfairly.
That's the concern. Financial regulators like the Consumer Financial Protection Bureau, CFPB, in the U.S. have been very clear. Using a sophisticated AI algorithm doesn't give a financial institution a free pass from fair lending laws like ECOA or the Fair Housing Act. The outcomes of the AI's decisions must be fair and non-discriminatory, and firms need to be able to demonstrate that they've tested their AI models for potential disparate impacts on protected groups and taken steps to mitigate any unfair bias found. That Treasury report summary also noted significant concern that AI might reinforce historical biases present in financial data, potentially leading to discriminatory lending practices or biased account closures, and urged firms to actively use bias testing methodologies and explore alternative data sources to improve fairness.
You mentioned multi-agent systems earlier. Does bias get worse when multiple agents interact?
That's a fascinating and worrying possibility, the challenge of bias propagation or amplification in multi-agent systems. If each individual agent in a team has its own subtle learned biases, their interactions might actually reinforce or amplify those biases across the system. Imagine several biased agents collaborating on a decision, like evaluating a job candidate or a loan application. If they all share similar biases, they might reach a consensus on a flawed or unfair outcome, and this agreement could paradoxically create false confidence in the biased decision. It could lead to systemic skew becoming embedded in the automated process.
It sounds difficult to detect and fix.
It does. It highlights the need for careful design in multi-agent systems, perhaps ensuring diversity among the agent's training data or perspectives to encourage constructive disagreement and counter each other's potential blind spots. Some researchers are even exploring the idea of deploying specialized oversight agents whose sole job is to monitor the interactions and decisions of other agents, specifically looking for signs of emerging bias or unfair outcomes.
So what can be done generally to mitigate these bias risks? What are the strategies?
There's a growing toolkit of mitigation strategies, though none are perfect. It starts with curating more diverse and representative training data, although that can be hard to achieve. Then there are various algorithmic techniques applied during model training or post-processing to try and reduce demographic disparities in outcomes while preserving accuracy as much as possible. Rigorous bias audits, often involving third-party experts, are becoming more common before deploying high-stakes AI systems. The concept of fairness by design emphasizes building fairness considerations into the entire development lifecycle from the outset.
Can you program fairness directly?
Sometimes you can try to explicitly program fairness objectives or constraints into the agent's decision-making process. And as mentioned, leveraging algorithmic audits, deploying oversight agents, or using techniques like generating counterfactual data, what if this applicant had different demographics, can help identify and address biases both before and during deployment. It's an active area of research and requires ongoing vigilance. So stepping back, regulators in both healthcare and finance and beyond are actively grappling with all these interconnected challenges: accountability, privacy, transparency, fairness. Comprehensive regulatory efforts like the European Union's AI Act, which is set to fully take effect likely around 2026 after its passage in 2024, represent the most ambitious attempt globally to create a binding legal framework.
What will the EU AI Act require for these agents?
For systems classified as high risk, which explicitly includes many healthcare diagnostic agents, credit scoring systems, systems used in hiring, critical infrastructure management, and law enforcement, the Act imposes stringent requirements. Companies developing or deploying these agents in the EU will need to implement robust risk management systems, ensure adequate human oversight capabilities, maintain high levels of accuracy and cybersecurity, guarantee transparency for users, keep detailed logs of the AI's actions, and continuously monitor for and mitigate bias. Compliance will be complex and costly, but mandatory.
What about the US? Is there anything similar?
The U.S. approach has been generally more sector-specific and based on existing laws so far, rather than a single overarching regulation like the EU's. Regulators like the FDA use their medical device authorities, banking regulators use their guidance on model risk management, and agencies like the FTC and EEOC apply existing consumer protection and anti-discrimination laws to AI. However, there's growing momentum. The White House issued a blueprint for an AI Bill of Rights in 2022, outlining principles like safety, non-discrimination, and transparency. And the National Institute of Standards and Technology, NIST, released its AI Risk Management Framework in January 2023. While voluntary, this NIST framework provides a very detailed blueprint for organizations to govern, map, measure, and manage AI risks comprehensively, covering everything from bias and robustness to privacy and explainability. Many expect parts of the NIST framework might inform future regulation or become de facto industry standards.
So lots of activity, but maybe less centralized in the EU.
Generally, yes. Financial regulators in the U.S. have also hinted at potentially requiring more disclosures from firms about their use of AI and the specific controls they have in place. We might see something akin to the stress tests banks undergo, but specifically designed for AI systems, AI stress tests, to evaluate how an autonomous agent handles unexpected market conditions, edge cases, or even adversarial attacks aimed at manipulating it.
So for any organization looking to use these autonomous agents, what's the takeaway message regarding regulation?
The key takeaway is that navigating the regulatory landscape is becoming increasingly complex and demanding. It requires a proactive and holistic approach. Organizations need to invest heavily in thorough validation and ongoing monitoring of their agents. They absolutely must involve legal, compliance, and ethics teams deeply in the AI development and deployment process, not just as an afterthought. And they need to stay agile and informed as new laws, regulations, and best practices continue to emerge rapidly around the globe. Because the risks of noncompliance, ranging from severe patient safety incidents and unlawful discrimination lawsuits to systemic financial errors and catastrophic reputational damage, are simply too high to ignore. Regulation in this area is only going to intensify as autonomous agents become more powerful and more prevalent in our lives.
Okay, so we've charted where we are now, the incredible applications, the key players, and the really significant challenges around safety, ethics, and regulation. It's a complex picture. But where are we headed? Looking forward, what's next for autonomous AI agents? What's on the horizon that will define the next generation of these incredibly powerful tools?
That's the million-dollar question, isn't it? If we try to connect the dots and look at the bigger picture, it's clear the field is evolving at just a breakneck pace. Several key trends seem poised to define the next generation of autonomous agents, making them even more capable and integrated into our world.
Okay, what's trend number one?
One major trend is likely to be much deeper integration with real-time and physical systems. We're going to see agents moving beyond just processing text and interacting with digital systems, connecting much more directly to the physical world.
Oh, so, like controlling robots.
Exactly. Think agents connecting to streams of data from IoT sensors, controlling robotics in factories or warehouses, managing smart grids, or interacting with edge computing devices. Autonomous vehicles and drones are, in essence, physical agents already, but future versions will likely benefit immensely from having LLM-style high-level reasoning and planning capabilities layered on top of their existing low-level control systems for navigation and perception.
So, smarter robots and vehicles.
Yes, and agents managing complex physical processes. In healthcare, for example, an agent might continuously monitor real-time data from a patient's wearable sensors or ICU monitors and make instant closed-loop adjustments, maybe fine-tuning insulin dosing for a diabetic patient, or optimizing ventilator settings for someone in critical care, all operating within strict preset safety bounds defined by doctors. In industrial settings, agents tied into factory sensor networks could dynamically manage complex manufacturing lines or optimize energy consumption in large facilities on the fly.
That requires incredible reliability, right?
Absolutely. As agents integrate more with these real-time physical systems, the emphasis will shift even more heavily towards extreme reliability, robustness, and low-latency decision-making. Mistakes in the physical world can have immediate and severe consequences. We'll also likely see a rise in multimodal agents, agents that can simultaneously process information from different sources, like vision from cameras, speech commands, text data, and sensor readings, all within one seamless reasoning loop. This enables much richer interaction with the real world, like a service robot agent that can see its environment, understand spoken instructions, and also look up information online using its tools. Some analysts predict that by 2027 or so, a large portion of new AI solutions will be multimodal, fueling this trend.
Okay, deeper integration with the physical world. What's next?
Next, I think we'll see significantly enhanced memory and long-term autonomy. One of the limitations of current LM-based agents can be their relatively short context windows or memory spans. They can sometimes struggle with very long, complex tasks that require remembering details from far back.
Right, they can forget things.
Exactly. Future agents are likely to feature far more robust and persistent memory systems. This could involve combining much larger context windows in the underlying models. We're already seeing models that can handle hundreds of thousands or even millions of tokens of context with more sophisticated external knowledge bases. Those vector databases we discussed will become even more important for efficient semantic recall of past experiences or learned information. We might also see more use of neurosymbolic memory architectures, where an agent maintains a structured symbolic knowledge graph of facts it has learned, alongside its neural network's pattern recognition abilities.
And what does better memory enable?
It unlocks truly long-term autonomous behavior. An agent that persists and genuinely learns or evolves over potentially weeks, months, or even years of operation. Imagine a personal assistant agent that actually remembers your preferences and past interactions from a year ago to provide truly personalized service. Or a business process agent that builds up an internal ledger of all the transactions it has handled, allowing it to identify trends and continuously improve its decision quality over time.
That sounds much more like a real assistant.
It does. Research prototypes like Stanford's Generative Agents study from 2023, which simulated AI characters living and interacting in a sandbox virtual town, already demonstrated that with robust memory architectures and recurring planning cycles, agents can exhibit surprisingly believable, coherent, long-term behavior patterns and social dynamics. We'll see significant improvements in how agents compress, organize, and retrieve memories efficiently, preventing the issue of forgetting critical details or constantly repeating past mistakes over long operational durations.
And better memory helps them learn better too.
Directly. Better memory is fundamental for more effective learning from experience. Future agents might increasingly employ self-improvement loops where they store significant past experiences, successes, and failures, and periodically replay or reflect on them to refine their internal strategies or policies. This starts to blur the line between a static, pre-trained model and a truly adaptive, continuously learning agent.
Okay, better memory, longer-term operation. What's the third trend?
A third pivotal development will likely be autonomous goal planning and self-improvement. Today's agents mostly follow goals explicitly given to them by a human user or optimize a fixed objective function defined by their developers.
Right, you tell them what to do.
Yes, future agents are expected to become far more adept at setting and decomposing goals autonomously. You might give them a very high-level, abstract directive, something like, improve our company's marketing ROI, or reduce operational costs in this division. And the agent would then figure out how to break that down into concrete sub-goals, identify necessary tasks, and execute them, perhaps even discovering entirely new objectives or strategies along the way that the human hadn't considered.
So they become more strategic.
Exactly. This involves advances in AI planning algorithms and maybe meta-learning capabilities. Agents will likely get much better at strategic reasoning, maintaining a high-level plan or intent in mind, rather than just reacting myopically to the immediate situation or prompt. Techniques like tree of thought prompting, where the agent explores multiple reasoning paths, or hierarchical planning architectures, perhaps using one powerful model to devise the overall strategy and other, smaller models to execute specific steps could become more standard.
And the self-improvement part. That sounds potentially scary.
It's definitely a powerful concept that needs careful handling. The idea is that agents could start to autonomously optimize their own performance. This might happen through reinforcement learning running in the background, where the agent gets rewarded for achieving goals more efficiently or effectively over time, or perhaps through evolutionary strategies, where different versions of an agent's internal algorithms or prompts are tested against each other, and the best performing ones are propagated.
So the AI literally gets better at its job by itself.
That's the direction. Imagine an agent that periodically analyzes its own performance logs, identifies where it got stuck or made suboptimal choices, and then autonomously adjusts its approach, maybe tweaking its prompting strategy, refining how it uses certain tools, or even, with appropriate safeguards and permissions, fine-tuning parts of its own underlying neural network model. Early versions of this might be simpler, like agents automatically A/B testing different ways of phrasing requests to external APIs to see which yields better results faster. But this kind of self-improvement loop moves us closer to truly autonomous AI that doesn't require constant human developer intervention to enhance its capabilities over time. It also raises profound questions about control and alignment, which ties into the final trend we'll discuss.
Okay, self-improvement is a big one. What's next? You mentioned collaboration earlier.
Yes, a fourth significant trend will likely be much deeper and more seamless human-agent collaboration and teaming. Rather than thinking of autonomous agents purely as replacements for humans, a lot of research and development focus is shifting towards creating effective human AI teams where humans and agents work together, leveraging each other's strengths.
The co-pilot idea again?
Exactly, but expanded far beyond just coding or writing emails. In the near future, we'll likely see many workflows redesigned around human AI partnerships. Agents might handle the bulk of the data processing, analysis, or routine execution, while humans provide strategic direction, handle complex edge cases, exercise judgment, and provide crucial oversight. Think of a medical scenario. An AI agent drafts a preliminary diagnosis and treatment plan based on the patient data, and then the human doctor reviews, critiques, and refines it in a tight, interactive loop.
So finding the right division of labor.
Precisely. Research on human AI complementarity is growing rapidly, focusing on figuring out which tasks are best suited for automation and which require human skills like empathy, creativity, or complex ethical reasoning. We also expect to see much improved interfaces for interacting with agents, moving beyond just text-based chat. We might see visual dashboards that clearly show an agent's reasoning process, its chain of thought, making it much easier for a human supervisor to understand what the agent is doing, intervene if necessary, or validate its conclusions at critical points.
So making the AI's thinking visible.
Yes. The AI co-pilot concept will likely broaden into virtually every knowledge work profession. We're already seeing pilots for collaborative agents in customer service call centers, where an AI listens to the call and suggests relevant information or responses in real time to the human agent. Or in creative fields like design, where AI agents generate multiple initial concepts or prototypes, and human designers then select, combine, and refine them.
What about multiple humans and multiple AIs working together?
That's another exciting possibility, platforms enabling multi-agent, multi-human collaboration. Imagine a virtual project meeting where several human team members are joined by several AI agents. Each may be acting as a specialized expert. For example, a data analyst agent, a market research agent, a risk assessment agent, all contributing to a brainstorming session or problem-solving process in real time.
That could be chaotic or incredibly productive.
Both are possible. As these collaborative models develop, critical issues will revolve around building trust and establishing effective communication protocols between humans and agents. Users need to understand an agent's capabilities and limitations, and agents need to be designed to effectively incorporate human feedback and guidance. Culturally, organizations will also need to adapt to having AI colleagues integrated into their teams. But this human-agent teaming paradigm is seen by many as a powerful way to keep the essential human in the loop for safety and judgment, while still achieving massive gains in productivity and capability.
Okay, human-agent teaming. What else is on the horizon?
Another key area of improvement will be in zero-shot and few-shot reasoning capabilities. Future autonomous agents will benefit immensely from the continuous improvement in the underlying foundation models they're built upon. As these models become more powerful and possess broader world knowledge, the agents using them will become much better at tackling tasks they haven't been specifically trained or programmed for.
So they can handle new situations better.
Yes, essentially becoming more general problem solvers. We already see impressive zero-shot abilities in models like GPT-4 or Claude 3, where they can perform a task reasonably well just from the description, without needing any explicit examples. As these models improve further with projects like Google's Gemini and others pushing the boundaries, agents built on top will inherit these enhanced reasoning and capabilities.
What does that mean practically?
It means you could potentially deploy an agent to a completely new task domain, say, asking it to help manage the finances for a small business it knows nothing about initially, and it might perform reasonably well right from day one. It could do this by drawing on its vast pre-trained knowledge about business and finance, using its reasoning abilities to figure out the steps, and leveraging its tools like connecting to accounting software via API, effectively, all without needing a custom algorithm coded specifically for that niche task.
That makes them incredibly flexible.
Hugely flexible. Additionally, the expanding ecosystem of tools, APIs, and plugins will greatly amplify what agents can do out of the box. With access to vast libraries of external capabilities, from booking travel to analyzing scientific data to controlling smart home devices, an agent could zero-shot decide to use a completely new tool if its reasoning suggests it's needed for the current goal. We might even see agents powered by AutoML, automated machine learning capabilities that could, on the fly, train or fine-tune smaller, specialized models for specific subtasks they encounter frequently, essentially building new skills for themselves as needed.
Wow, learning new skills automatically.
Potentially. All of this drives towards agents that are highly adaptable, versatile, and not confined to one narrow, predefined domain. Of course, ensuring reliability and safety in these zero-shot or few-shot scenarios remains a significant challenge, so this trend absolutely goes hand in hand with the need for more rigorous validation methods and robust testing, likely involving extensive simulation. Before deploying a highly adaptable agent into the real world, especially for critical tasks, organizations will need to test its reasoning and behavior extensively in safe, simulated environments, maybe a virtual replica of a hospital ward, a simulated stock market, or a digital twin of a factory floor to gauge the robustness and safety of its zero-shot capabilities under a wide range of conditions.
Makes sense. Safety first. Okay, that brings us to the last trend, which feels like it connects back to many of the challenges we discussed.
Indeed. The final and arguably most crucial future direction is the ongoing development of ethical and alignable agents. As agents become more autonomous and more capable, the potential risks of them causing unintended harm, pursuing goals in undesirable ways, or becoming uncontrollable naturally increase. Therefore, there's an enormous push in the AI research community and industry to develop robust techniques for ensuring agent alignment.
Alignment meaning making sure they do what we actually want them to do safely.
Precisely, making sure their goals and behaviors align with human values and intentions and avoiding harmful side effects. This is often referred to as the AI alignment problem, and it's a central challenge for developing advanced AI safely.
So how do we build ethical constraints into these agents?
There are several approaches being actively researched and implemented. We already mentioned Anthropic's constitutional AI, which tries to bake in core ethical principles directly into the model's training process. OpenAI and DeepMind are working heavily on techniques for scalable oversight, where AI systems themselves might be used to help humans supervise and evaluate the behavior of other, more complex AI agents, because human oversight alone might not scale to monitoring millions of autonomous agents operating simultaneously.
AI policing other AI.
That's one fascinating idea being explored. As one Gartner analyst quipped, we might need AI watchdogs whose job is specifically to monitor fleets of other autonomous agents, perhaps auditing their decisions for fairness, flagging policy violations, or detecting risky emergent behaviors that could lead to system failures. We also expect to see the development of new frameworks and architectures that make agents inherently more transparent about their reasoning processes, specifically to facilitate human auditing and understanding, and architectures that allow developers or users to more easily insert specific ethics modules or hard-coded safety constraints.
Like Asimov's laws of robotics.
Sort of, but likely more practical and context-dependent. For example, an agent operating machinery might have a non-negotiable, hard-coded rule preventing it from taking any action that could plausibly cause physical harm to a nearby human. A financial trading agent might have inviolable rules against exceeding certain risk limits or engaging in prohibited trading practices, regardless of the potential profit. These constraints act as safety overrides.
And aligning with individual values.
That's another important dimension value learning. As agents become more personalized, like personal assistants, there will be progress in techniques allowing them to gradually learn and adapt to the specific preferences, priorities, and values of the individual user or organization they serve. Your personal AI assistant, over time, should ideally come to understand your risk tolerance, your communication style preferences, perhaps even your ethical stances on certain issues, and tune its behavior accordingly. So overall, the future trajectory aims for agents that are not only significantly smarter and more autonomous, but also demonstrably more governable, predictable, and aligned with human interests. This isn't just a technical goal. It's increasingly being driven by regulatory pressure and public expectation as well. By integrating ethical guardrails and robust safety mechanisms right from the design phase, and by providing effective tools for ongoing monitoring and human intervention, the hope is to prevent nightmare scenarios of agents going rogue or causing widespread harm. In the longer term, this entire research direction directly intersects with the broader critical discussions around ensuring the safety of potentially transformative artificial general intelligence, AGI, making sure that as our AI systems become ever more powerful, they remain firmly under human control control and provably beneficial to humanity. So these trends we've discussed deeper, real-time, and physical integration, vastly enhanced memory enabling long-term autonomy, more sophisticated autonomous goal planning coupled with self-improvement capabilities, seamless human-agent collaboration becoming the norm, powerful zero-shot generalization, and a fundamental commitment to building ethical and alignable systems that collectively paint a compelling picture of the next generation of autonomous agents. We're looking at systems that promise to be vastly more capable, incredibly adaptive, and hopefully significantly more trustworthy than what we have today. If this potential is realized responsibly, with careful attention to the risks and ethical considerations, these agents could truly revolutionize productivity, scientific discovery, and societal problem solving on a global scale. The next few years will be absolutely pivotal in translating these research advances into practical, safe, and genuinely beneficial agent implementations across every facet of our lives and work.
Wow, that's quite a future unfolding. From the foundational architectures and the underlying tech to the incredible real-world applications already transforming industries like healthcare and finance, and then grappling with the immense ethical and regulatory tightrope we're clearly walking. This has been an absolutely incredible deep dive. It really underscores just how fast this field is moving and how truly profound its implications are for all of us.
Indeed. It's been fascinating to track. The journey of autonomous AI agents is, in the grand scheme of things, still very much in its early stages. There's so much more development to come, but the trajectory seems clear. They are poised to become indispensable tools, powerful extensions of human capability, augmenting our intelligence and helping us tackle problems at scales and speeds that were previously unimaginable.
But with a big if,
Yeah,
right?
a very big if. For this enormous potential to be fully realized in a way that truly benefits society as a whole for the greater good, we absolutely must proactively and thoughtfully address the significant challenges. We have to mitigate inherent biases, we must establish clear lines of accountability, we need to demand and enable transparency, and most fundamentally, we have to dedicate ourselves to aligning these incredibly powerful systems with our core human values and ethical principles. It's truly a societal endeavor, perhaps just as much, if not more so, than it is purely a technical one.
So what does this all mean for you listening right now? As you inevitably encounter more and more of these autonomous agents, maybe in your healthcare interactions, your financial services, the tools you use at work, or even just in how information is processed and presented to you online, consider this. How will we, as individuals and as a society, ensure that as AI agents become increasingly autonomous, perhaps even starting to set their own goals or improve themselves, they remain truly beneficial? How do we guarantee they continue to serve humanity's best interests, enhancing our lives rather than diminishing them? That's a thought worth mulling over until our next deep dive. Thank you so much for joining us today for this exploration of autonomous AI agents. We hope you'll continue exploring this fascinating topic and keep asking the important questions.